Okay. Class, bear in mind for the second half of our semester, in which after the semester break, okay, mostly I will focus mainly to the content which is essential for your final exam. Okay, so I will more focus towards that lah, rather than uh, uh, going through all the contents. Okay, so you can therefore you can focus lah to the slides or the lecture that I have taught during the second half. Okay. Okay, so most probably for your final exam, okay, the content that could be asked in your final exam start from the assembly language, okay, the processor until the end. Okay, so those lecture topics before the assembly language not included in your final exam. Okay, therefore now you can turn off your cam so that you can save your bandwidth, you can save your credit. Okay, and just on the mic whenever I ask you a question or I would like to ask for volunteer. Okay. Okay, class. Okay, for today's topic, the topic is the pipelining. Okay, so don't worry. Okay, this topic I have just edited. Okay, and I will share to you very soon. Okay, so don't worry much. This one I haven't shared to the you learn, and I will share it soon. Okay. Okay. Okay, so pipelining is if it is the analogy, you can imagine a pipe, okay, being being buried underground. Okay, so if there are several pipes, okay, means that all the pipes we can stack together lah. Okay, means that, okay, if you have about 8 pipes, okay, means that the water can flow, okay, uh, in parallel, okay, for the 8th pipe, okay, in 1 second, right? Okay, so in terms of bandwidth, we can say as 8 megabits per second lah, right? Right. So pipelining is something like that, and the other analogy is just like the process of doing laundry. Okay, laundry ataupun you basuh baju dekat laundry lah. Apa laundry Okay. Okay, so you can imagine whenever you want to wash your cloth in let's say apa ni layan diri, dobi layan diri. In Malay we call as dobi layan diri. What is we call in English? I forgotten already. Self what for layan diri? Anybody can help me?
Self
Self?
laundry.
Self laundry. I forgotten the word for layan diri.
Self-service.
Self-service. Okay, thanks a lot for helping me. Okay. Okay. So kalau you imagine, okay, whenever you want to do laundry and at the laundry shop, okay, you can see several person will queue, right? Because in order to perform the laundry, okay, just like the story of Mr. Bean, okay, you have to queue, okay, and then you have to wait, okay, until the wash process ends. Then only the other customer can wash their clothes. Okay. Okay, so imagine after you have washed your clothes, is it dry? Is it the clothes dry or not yet? Class, when you perform the wash?
Not yet.
Not yet, right? So you need to do what? After that, after wash.
Dry.
Okay, you have to pass into the dryer, right? Okay. Okay, so you can imagine the process of waiting. It is just only for one customer. Okay, if it is in sequence. Okay. So whenever you there are queue, several customer want to perform laundry, okay, so if it is in a queue, okay, the following customer have to wait until the first customer ends their washing process, then only the second customer can wash, and then the first customer will bring their clothes and put into the dryer machine, right? Okay, and if it's only 2 person, can you imagine about maybe 20 person? how long it takes, right? Okay. Okay, that is the idea of pipelining lah. You can imagine a laundry system. So it actually reflect, okay, the instructions in your assembly language. Can you still remember in your assembly language? Okay, your program or assembly language, okay, consists of multiple instructions. Am I right, class? Is it true?
Yes.
Yes. Okay, right. So the previous one that you have done in Qt Stream, it consists about 5 or 6 line of codes, right? Okay, what about the flow of the codes? Is it in sequence? Am I right, class? In sequence, right? Am I right? You have to finish the first instruction, then only the second instruction can be executed. Is it true, class? Is it true? Class, is it true? In order to run the second instruction, you have to finish executing the first instruction. Am I right, class? Betul ke?
Yes, correct.
Okay.
Yes.
itu baru 2 instruction. But if your assembly language consists of thousands of instruction, let's say one instruction consists of 20 picosecond. Okay, so if you have 5 instruction, what is the total duration in order to execute your program? One instruction consists of 20 picosecond and you have 5 instruction. Okay, the total of how many picosecond, class, for one program?
100.
Okay, 20 per instruction and times 5 instruction. How many the total? Total duration. 100, right? Am I right? 100 picosecond, class? Betul ke?
Yes, 100.
Okay, 100. So this is what we meant by the pipelining. So if we didn't perform pipelining, all the instruction will be executed in the form of sequence. Okay, jadi it is waste of time. Okay, because we know that one instruction, okay, consists of how many machine cycle, class? How many data path? The one that we have learned earlier. Start with what? From the letter F. What is that?
Fetch.
Fetch. And then
Decode.
decode, execute, right? And then we decide whether we have a memory operation or we need a register store. Am I right? So please remember the process. So even in one instruction consists of these 5 steps. Okay, so let's say one data path, okay, ataupun one process such as fetch consists of 20 picosecond. Okay, then we have 5 steps. Okay, start from fetch, decode, execute, and then memory as well as apa ni, register store. Okay, so it consists of 5 steps. So 5 times with 20 picosecond. So for one instruction takes about 100 picosecond. That is only for one instruction. So let's say we have thousands of instruction. Therefore, your program will be taking a lot of time to be executed. So nowadays, or today session, we will learn about the pipelining, how we can utilize or we can improvise, okay, or we can improve, okay, the processing speeds of running an instruction using a technique we call as pipelining. Okay, okay, can you get the basic idea, class? Get it? Get it, class?
Yes.
Okay, so, so basically I can go through with you first, okay, the so that you can get a rough idea about pipelining. Okay, like this lah. Okay, okay, previously the analogy that I have mentioned to you just now, okay, we have several customer want to perform the laundry. So laundry, we have the wash process, we have the dryer process, okay, folding the cloth and then put it into the drawer lah. Okay, right? So let me go to the following slides. Okay, so this is what the normal sequence will be. Start with wash. Okay, so this one steps is equivalent to, or one person is equivalent to one instruction. Okay, so the following one is the second instruction. Then we have the third and fourth and so on. Okay, so in order for the second customer to get back their cloth, Okay, they have to wait until the first customer end their process. Okay, starting with the wash, and then after wash, dryer, and then waiting for the apa ni, the staff to fold ataupun lipat kain. Okay, and then only they can return, or you can hand over to the customer, back to the customer. Then only the shopkeeper, okay, or the staff will attend the following customer. Okay, can you see here the time consuming process? Can you see here? In order to go to the following instruction, okay, or in order to go to following customer, okay, the first customer have to complete everything first, and it takes about 30 times 4, or it is equivalent to 120 picosecond. Okay, can you get the basic idea, class? Get it?
Yes.
Okay, so this one we call as sequential laundry. Okay, but in pipelining, okay, now I show you the pipelining. Okay, okay, okay. By doing pipelining, okay, we can process, okay, the other tasks, okay, whenever the first machine is not being utilized anymore, such as, okay, the first customer, firstly they will do the wash. Okay, after the customer have done the wash, the first customer will empty the washer, right, will empty the washing machine, right, and put into the dryer, right. So what about the washing machine? Is it empty, or can it be used now, class?
Yes,
Can
it
it be
can.
used now because it is empty now, right? Okay, so the second customer can perform the wash while the first customer can do the dryer. Okay, get the idea, class? Get the idea, class?
Yes.
Yes,
Okay,
sir.
and then when the first customer, okay, the staff is doing the folding part. Okay, now, okay, the second customer have finished doing the washing, and the second customer can do the drying through the dryer. Okay, therefore now the washer is empty or idle. Okay, so it is can be used by the third customer. Okay, so this is the idea of pipeline laundry, in which, okay, the instruction, okay, few instruction can be executed or can be loaded at the same time when we perform the pipelining concept. Okay, if you want to snap, you can snap it, or you can copy the notes later. Okay, so this is the sequential laundry, or this is the normal sequence of your assembly language program. You will execute one instruction after another. Okay, but by having pipelining concept, you can run multiple instruction at the same time. Okay, so we back to our first slide. Okay, okay, the second slide. Okay, so agenda today. So you have briefly seen about the concept of pipelining, right? Okay, right. So later on I will describe to you about pipelining. Before that, we will go through about I-type instruction in order to show you, okay, the breakdown process under each instruction data path, or machine cycle. Okay, so for today's part, we will discover about I-type instruction. Okay, and finally implementing pipeline in single cycle data path. Okay, right. Okay, are you ready to go to the following slide, class? Can we?
Yes.
Yeah. Okay. For example, okay, don't worry much about the instruction. I just want to show you about the details steps under each of the instruction. Okay. So you know, if you run the instruction in sequence, let me have the pointer. Okay, if your program consists of multiple instruction, they will run the first instruction first. Even the first instruction consists of multiple stages, right? Okay, store word $sign T3, okay, comma 17, which is the offset. Okay, bracket T1. T1 is referring to the content of T1. Okay, so don't worry much about this. Okay, so I just want to show you today about the stages. Okay, right. Okay, what is the first stage in data path or machine cycle, class? What is the first stage? Tell me.
Fetch.
Fetch. Nama.
Syafika.
Nama? Syafika. Okay, bagus Syafika. Okay, okay. Anybody want to tell me the following steps after fetch?
Decode.
Okay, nama? Nama?
Aliana Syuha.
Anashua, Okay, selepas decode apa Anashua?
Execute.
Execute lah. Okay, compute or execute sama lah. Lepas execute, memory kan. Okay, kena ingat store. Okay, fetch, decode, execute, store. Tapi store tu we can break it up into two store. Whether it is a memory or the second one is the register involvement. Okay, class? Get it, Nashua? Right? So you please remember the details stages for each of the machine cycle or each of the instruction will run these detail stages. Okay. Okay, but for the time being, for this instruction, how many stages involved? Is it 5 or is it 4? How many stages involved for this instruction, class? Is it 5 or is it 4? Which one? For store word. Okay. Volunteer please. Tadi siapa nak jawab? 4 or 5 stages? 4. Excellent number. Nashua. Aida. Okay. So the correct answer is 4. Why 4? Because stage 5, nothing to write to register. You see here, ideal. Ideal means that this step is being skipped. Okay, so this is what we call as the detail stages lah. It is just like just now you saw the laundry, right? You saw the laundry. Firstly, you do the washing. Okay, after you perform the washing, you perform the drying. Okay, suddenly after that, you tell the shopkeeper, no need to fold for you. So you have ideal, or you have skipped the third stage. Okay, so so for each of the instruction, you have to remember the instruction consists of how many stages. Okay, so basically for data path or machine cycle, okay, in general, okay, can have about 5 stages. Okay, about 5 stages, but it is not compulsory. Okay, like for store word, it is only involve 4 stages. Why? Because the station number 4, okay, is not being utilized, or it's not being performed because nothing to do with register at the end. Okay, are you clear, class? Is it clear? Is it clear, class, about the stages?
Clear, sir.
Okay, so just take note, this one for the store word, okay, only consists of 4 stages. Okay, right? Okay. Okay, so the question is, could we have different number of stages? Yes, the answer is yes. Okay, and other architecture do. Okay, so why does MIPS have a 5 if instruction tend to be ideal for at least 1 stages, right? Okay, so MIPS can have up to 5 stages lah. So it is actually 5 stages, but the last stage is ideal lah. It's not related to the store word instruction. Afterward, I will show you an instruction which require 5 stages altogether. Okay, so 5 stages are the union of all the operation needed by all instruction. Okay, so in general, okay, for MIPS instruction, it can be up to 5 stages. Okay, okay, one instruction use all the 5 stages. Normally, we use as instruction load word. Okay, so the following instruction will consist of 5 stages. Okay, okay, let's investigate this instruction. Load word, okay, assign T3, okay, okay, offset 17, okay, or this is the immediate value, okay, immediate value, okay, okay, and then this is the register. Means that, okay, okay, the content of register T3, okay, let's say the content of register T3, okay, okay, is 5. The content of register T3 is 5. Okay, right. Okay, and the content of register T4, okay, okay, register T4 Okay, let's say the content of register T4 is 4004. Okay, right? Okay, you can copy this one first. Okay, I just give an analogy. This is not what we say mandatory answer. Okay, so I just want to give a general overview. Okay, this is not the correct the 100% syntax lah. Okay, so T3 is FA, which is FA, and the content of memory location T4 is 4004. So actually, okay, this means that we are referring to the content of T4. So T4 is actually, okay, referring to memory location, or the RAM. Okay, memory location. Okay, right. Okay, memory location. So I draw it using mouse, so could be not that beautiful lah. Okay, right. So we can have memory location 4004. Okay, right. Okay, and then I draw another memory location. Okay, later on maybe I can draw it nicely using the Excel, like the one that I have done previous weeks. Okay, right. So I just do it roughly here. Okay, what is the memory location after 4004 class? What is that?
4005.
Excellent. Okay, sambung. Okay, lepas tu 4006.
4006.
Okay, lepas tu
4006.
sorry lah, saya lukis tak cantik. 4007. Okay, right. Okay, right. Okay, let's say the content of memory location 4004 is phi F1 phi F1. Okay. Lepas tu apa okay, apa lagi content you want to insert in 4006? Okay, can you give me any hexadecimal value? F1 lagi? AF lah. Okay, let's say 4006 is AF. Okay, 4007 is IF, Afif. Okay, bukan Afif 1F, sorry, 1F. Okay, 1F. Okay, so it is not that beautiful lah, sorry Okay. Okay, this is memory location 4007. Okay. Right, so currently okay, the meaning of a load word T3, okay, comma 17 plus with okay. It is quite fine, so I think I better make it a little bit shorter lah. 1 2 4001. Sorry. Okay, this one supposed to be T4. Okay, my mistake. So this one supposed to be T4. Let me clear it first. Okay, right. Okay, this one supposed to be where is the pointer? Laptop tani tend to have a typo right. Okay, so it's not T4 supposed to be T1. My mistake okay, my mistake. Okay, so okay, so I make it a simpler lah. Okay, instead of 17, okay, just for this to show you instead of 17 I change this one to 3 I change to 3. Okay, 17 I change to 3. Okay, right. Okay, so please bear in mind regarding the typo that I have written just now. Okay, right. Okay, so currently, you can copy the content of the memory location. Okay, so we have T3 here. Okay, and then this one supposed to be T1. Okay, and the immediate value I change to 3. Okay, Okay. Are you ready, class? Are you ready? Are you ready, class? Can I continue? Okay, right. Okay. So the meaning of this instruction is the memory location pointed by T1. So you refer to T1. So T1 is referring to the memory location 4004. Okay, so let me clear the so that I can use different color. Okay. Okay, so maybe I use the blue color. In color, try to use this color. Okay, so the instruction load word, okay, T3, comma 3, okay, bracket T1, bracket, okay, the meaning of this is actually, okay, we are copying the content of memory location, okay, pointed by T1. Okay, so what is the memory location, what is the content of T1, class? Tell me. What is the content of T1? What is the content of T1? The answer is in this slide. What is the content of T1? Quick, the answer is in this slide. What is the content of T1? Dia tengok T1. Cari kat mana T1. Kotak dia. Okay, what is the content of T1?
T3.
Okay, tak, the content of T1 is what? Firstly, before we add.
400.
4004, kan? You see here, the content of T1 is 4004. So it's actually, okay, you are referring to the content of memory pointed by T1, okay, which is 4004. So you point, okay, you point to memory location 4004. Okay, but it is not finished yet. Why? Okay, because in order to execute instruction, okay, this is equivalent to the memory location pointed by T1, but you have to plus with 3. You see here? 3 memory location. Can you see here, class? Nampak? See? Class, can you see the 3?
Yes.
Yes.
Okay, so you have to plus 3 memory location. Means that 4004, it is just like 4, okay, 004. Okay. Okay, plus with, okay, not 17 lah, kita dah tukar tu 3, right? Okay, so plus with 3, right? Okay, so have you need to press a calculator? What is 4004 plus 4 plus 3? What is the answer? 4007. Okay, so now I use different color maybe. In color, what color should I use? Maybe I should use green color. Okay, so now it is referring to memory location 4007. So you find out where is memory location 4007. Okay, so 4007 is here, right? Okay, what is the content of memory location 4007, class? What is the content of 4007?
1F.
1F. Okay, so memory location pointed by T1 plus with 3, the content is equivalent to 1F. Okay, okay, so if you are performing the load word, okay, T3, comma 3, okay, bracket T1, so it's actually you're copying the content of memory location pointed by the T1 plus with offset 3, okay, plus with 3 memory location. This one you copy into memory location T3. Okay, right? So you can see here, T3 is equivalent to memory location T1 plus with this displacement or 3 memory location. Okay, so currently what is the answer? What is the content of T3? Can anybody tell me? Boleh cuba, salah pun tak apa. What is the content of T3, class? 1F, very good. Okay, nama siapa?
Shafika.
Shafika, excellent. So the content of T3 now is equivalent to 1F. So this is the meaning of this instruction. But don't worry much. Okay, I just want to give an idea lah. Okay, so this one we can analyze later lah. So because the intention of this lecture is not to get to know in depth about the instruction, but just to describe about pipelining. Okay, right. So I think This one I better discard changes. Okay, right. So I rerun again. Okay. So this one that we have done just now, right? Okay, so just now I changed this one to 3. Okay, doesn't matter. So now we back to 17 lah. We back to 17. It is just a matter of number, Okay, sebab kalau I buat 17, okay, can you imagine just now? Let me go back to this diagram. Okay, if we add with 17, can you imagine how many boxes should I add? You get the idea or not? If I using plus 17, so it will requires a lot of boxes. You get what I mean, class? Class? You get what I mean? Why I changed from 17 to 3? Class? Get it?
Yes, sir.
Okay,
Yes, sir.
because if I use plus 17, it will requires a lot of boxes lah, and we will be more confused lah. So that's why I'm changing to 3. Okay, so that I can give you an overall idea. Okay, don't worry much about that because our focus today is not toward understanding the instruction. Okay, so the focus today, let me get the pointer. Okay, our focus today is to understand about pipelining or detailed stages. Okay, right. For load word, okay, you think how many stages involved for load word? How many stages of data path or machine cycle for load word? How many stages?
5.
5. Okay, so firstly we fetch the instruction. Okay, secondly, we decode to determine the meaning of load word. Okay, so if in order to find the meaning of load word, okay, you have to investigate what? The opcode, right? You have to you have to investigate the opcode for load word. Okay, in which in order to investigate the opcode for load word, you have to refer to this MIPS green sheet, right? You have to refer to MIPS green sheet, and you can find the load word. So where is the highlighter? Okay, so you find the load word. Okay, load word. Okay, what is the opcode for load word, class? In your opinion, what is the opcode? The answer is there. Okay, what is the opcode for load word? 2, 3. Okay, the opcode for load word is 2, 3 lah, as you can see here. Okay, so firstly, the CPU will investigate or decode. Okay, decode in order to understand what is the meaning of that instruction. Firstly, the CPU will investigate the opcode, which is the load word, and the load word opcode for load word is 32. Okay, you can copy 32 base 16 lah, or 32 hex. Okay, in hex, right? Okay, 32 if you change to binary. Okay, what is the binary equivalent for 32 class for hex? Ke bawah lah, silap. It's supposed to be to right to the bottom. Okay, point option, I have the eraser. Okay, now you think about it first before we continue. Okay, because we know that machine only understand binary numbers or the shorthand, which is the hex code, right? Okay, right. That's why the opcode, the assembly language that we understood is load word. But for machine, they only understand binary numbers and hexadecimal code. Okay, so the hex code in the form of what base, class? 32 what base?
16.
16, right? So to binary, okay, how what is the equivalent binary for hex for 32?
0, 0, 1, 1.
Okay, this one is 0, 0,
0,
1,
1, 1.
0 kan? Okay, ini adalah 0, 0, 1.
1-1.
Okay, is it correct, class? Betul ke? Betul correct right? Okay, so this one we omit lah. Okay, so we know that the opcode is only 6 bit. Okay, opcode how many bits, class, for opcode? 6, right? Therefore we can omit the leading zeros. So 1 1 0 0 1 0. So this one is the opcode lah. Okay, so remember how we analyze the field for each instruction. The instruction format start with opcode, can then register what? Register what? Shift amount if there is available or if it is immediate value. So therefore they don't have the shift amount. Then straight away we have the immediate value. Okay, right. Don't worry about that. Let me have the pointer again. Okay. Okay. After we have decode, determine. Okay. What is the third step, class? What is the third step after decode?
Compute.
Compute or execute, right? Fetch, decode, execute, in which we compute or we add, we perform the operation. In order to process, we need to understand first what is the meaning of instruction. So load word means that we are loading the contents of memory location pointed by T1 plus with 17 memory location, and we copy into register T3. Okay, right? Okay, so means that now we are reading from memory, right? So that's why we have the read value from memory, right? Because now we are referring to memory location. Am I right, class? Is it true, class? Betul?
Yes, sir.
Okay, so you are reading from memory. Therefore, the fourth stage involved, we read from memory. Okay, finally, after we perform the instruction, what is the final task that we have done? We need to do, or the CPU need to do. The content of memory location pointed by T1 plus with 17 memory location. Okay, we get the content and store where? Store into
Memory.
register.
Memory.
Ni T3 register ke memory, class?
Register.
Register, dia terbalik. Dia the other way around. So we are looking for the memory location pointed by T1 plus with 17 memory location. Okay. So remember just now I show you, right, the memory location. Jangan lupa. Then you find out what is the content of that memory location and we copy it or we load it into register T3. So is it register involved for the stage 5? Register involved or not?
Yes.
Yes, that's why for this instruction load word, okay, we are involve 5 stages. Okay, so are you clear, class? Okay, the difference that I'm trying to tell you, the 4 stage instruction and 5 stages instruction. Are you clear, class? Is it clear?
Yes, sir.
Okay, so we move on to the following steps. Okay, so this is the the diagram that shows the 5 steps or 5 stages involved for load word instruction. Okay, firstly, the PC, okay, the program counter will point to the address of the first instruction. Okay, it will refer to instruction memory. Okay, right? Okay, in which if we have the load word, okay, it consists of X, okay, and then consists of first register and third register, okay, right? Register T1, okay, and register T3, okay, right? Okay, okay. Then after that, okay, after they have determined, decode the instruction, okay, they know that, okay, they have to add with 17 memory location, right? Okay, so they are referring to register 1, okay, which is the content of register 1, okay, add with 17. So here, okay, the content of register 1, okay, plus with 17 being done by ALU. Okay, so ALU will compute, okay, will add the content of register 1 plus with 17. Okay, so the following step is, okay, they will get the result lah. Okay, register content of register 1 plus with 17 memory location, and then it will go to the following steps, which is the load word. Okay, load from memory, right? Okay, remember the load word means that we are loading the contents of memory. Okay, okay, and then we store the content of that memory location into register. Which register, class? T3. Okay, and the result will be stored in register T3. Okay, and then if you see here, okay, the arrow goes back to PC means that it is the end of the first instruction. Then PC will fetch the address of the next instruction. Okay, right? Okay, any question, class, for this slide? Are you clear so far?
Yes, sir.
Clear, eh? All right. Okay, so this is the details description for the data path or the detail stages for the load word instruction. Okay. So we are trying. Okay, so why is it this one appear? I think I skip first. Discard. Okay, where is slideshow? Okay, I want to clear the taskbar just now. Okay, class. Okay, now I get back the pointer. Where is the pointer? Pen. Okay, right. Okay, so this diagram will illustrate the detailed steps lah. Whenever we execute single steps, or we are examining the details of each instruction. Okay, please bear in mind, this is a popular question. Okay, it is commonly asked in any assessment. Okay, they will give this diagram and they will ask you to elaborate. So you need to know how to describe this diagram lah. Okay, right? So this is the data path steps involved lah for each of the instruction. Okay, so we start now. Okay. Okay, so firstly, okay, the PC will point to the address of memory location 40060. So okay, I cannot open the Excel. Okay, so for 004060 is the memory location where it store the instruction. Okay, so the instruction that we are executing now is load word. Okay, T3, 17 bracket T1. Okay, okay, so I hope you already understood about this instruction. Okay, okay, for this instruction, okay, it is also another popular question. Okay, the question or the exam question might ask you to translate from this assembly language into machine language. Okay, okay, you get my question, class? You get my question? Translate this assembly language into machine code or hex code or machine language. Okay, okay, you understand my question, class? Get it?
Yeah.
Yes, sir.
Okay, so please translate for me from this assembly language into machine language, right? Okay, load T3. Okay, so in order to do this, you have to remember the format lah. Okay, what is T3? What is T1? Okay, so you have to refer from the previous notes that I have shared to you, right? Okay, right. So after we have done the conversion, okay, so this is the equivalent machine language, okay, or the machine code for load word T3, 17 bracket T1. Okay, okay. Actually, I have done in Excel, but the I'm not able to run half a slide and the other half for Excel. Okay, or else the animation is not running lah. Okay, right. So for T3 17. Okay, for assembly language, so it is equivalent to 8D 2B 00 and 11. Okay, okay, right. Okay, so when we translate into binary number, okay, so for 8D we'll get this one. Okay, 8D. Okay, so this one equivalent to 1000 is 8. Okay, okay, this one is 8 plus what? 8 plus what, class? This one for the second nibble. 8 plus this one is equivalent to what? 2 power of 2, right? What is 2 power of 2, class? What is 2 power of 2?
4.
4. Okay. Okay. This one 0. What about this one? 2 power of what?
1, 2 power of 0.
2 power of 0. 2 power of 0 is what?
1.
1. 1 plus with 4. 5 plus with 8. Okay. What is that? 13. Is it 13?
Yes.
Yeah.
What is 13, class? D, right? Is it D? 13?
Yes.
All right.
Yes.
Okay. That is how we translate from hexadecimal code, hex code into binary numbers. Then you can try the following one. Okay, the following one is 0010. Which one is this? From which one?
2.
2.
2. Very good. So it is equivalent to 2. Okay. This one equivalent to 2. Okay. Okay. What about this one? 1011 equivalent to what? 8 plus with?
B.
8 plus with?
2.
2 plus with? 1.
1.
Okay. 8 plus 2, 10 plus 1, 11. So what is 11?
B.
B, right? Get it? So this is what? Then we have 0, 0, and then we have 0, 0, and then we have 1, 1. Okay. Okay. Clear, class? So I clear this one first. Okay. So you have cleared this part. Okay. So now you know that. Okay. The conversion. Okay. Okay. From this assembly language. Okay. Okay. It is equivalent to a machine language. Okay. Machine code or hex code. Okay. Or hex code. Machine code MC, short form as MC, or hex code. Okay. Okay. Hex code for load word $sign T3, 17 bracket T1. So it is equivalent to 8. Okay. D. Okay. Please tell me what is the hex code, class? 8D lagi? To what?
B.
8D to
B.
B. Then
0, 0, 1, 1.
0, 0, 1, 1. Okay. Right. Okay. So okay, the top instruction is the assembly language which is familiar to you as a human. Okay, familiar to you as human. But for machine, okay, they only understand binary numbers, okay, or hexadecimal code in the form of shorthand or hexadecimal number. Okay, okay. So from this code, okay, okay, are you still remember? Okay, how to break it up into instruction format? Okay, or you already forgotten? Do you remember, class? I still remember. Please respond quickly. Remember or forgotten? Doesn't matter. It doesn't matter, right or wrong. Okay. Okay. So partially. Okay. Very good. So basically from this binary numbers, okay, okay, you have to separate it, or you have to distinguish which one is opcode, okay, which one is RS, RT, and immediate value. Okay, class. Okay, so you can see here, if you perform the arrangement, okay, it will follow from right, left to right. Okay, okay, left to right. Okay, so you will arrange this one 1 0 0 1 1. Okay, okay, how many bits for opcode, class? How many bits for opcode? It is very common. How many bits for opcode? 6 bit, right? Okay, so we have a 6 bit for opcode. Okay, therefore you only take the 6 bit. Let me clear. Erase. Okay. Okay, so you only take the 6 bit 1 2 3 4 5 6 until here. Okay, okay, so this 6 bit you put under opcode. Okay, and the rest, okay, will be to the RS, RT, and immediate value. Okay, RS, RT, and immediate value. Okay, right. Okay, so this is the RS. Okay, 0 1. Okay, so I think I should use different color. In color, maybe I use green. Okay, right. So for RS, we'll start from 0 1 until what, class? Until 0 1 0 0 0 1. Okay, right. Okay, so what is the value of this, class? In decimal, it is equivalent to what? 8 plus 1. What is that? 9, right? Am I right? 9? Still get 9.
Yes.
Okay,
Yes.
so this one, okay, so this one equivalent to 9 and so on. Okay, right? Okay, so don't worry much about this. So we clear this one first. Okay, Right. Okay, so the first thing is in order to run this instruction, okay, firstly, okay, the PC will point to the address of memory location. Okay, right. Okay, and then it will look for the opcode. Okay, okay, it will look for the opcode. Okay, right. Okay, so for load for this one, for the load word, okay, the opcode is equivalent to what? 23, right? So if you have forgotten, okay, let me open the okay, the sheet again. Okay, load word is equivalent to 23, right? Okay, okay, that's why when the CPU see 23, it knows that this one is for load word. Okay, so if you this number you change 100011, okay, this equivalent to 3. Okay, equivalent to 3. Okay, right. Okay, so we execute again. So that's why I'm telling you that if I want to show the other PDF or I want to show the Excel, okay, I need to end the slideshow. So because if I end the slideshow, the animation doesn't work. Okay, right. Okay, so firstly, okay, after reading the instruction, okay, firstly the CPU, okay, will read the opcode. Okay, right. Okay, so the opcode is being copied here, which is 100011 equivalent to 23. Okay, okay, 23 is for what, class? 23 is for load word. Still remember? Still remember, class?
Yeah.
Yes.
Yes, sir.
Okay, so it knows that this instruction referring load word. Okay, then follow with the following instruction. Okay, which is 1001. Okay, so reading the first instruction. Okay, right, and then okay, they will perform the following instruction. Okay, which is referring to the register, the content of register T1. Okay, and then they will add with the value. Okay, this one too fast. Okay, okay, they will add with the value 17. Okay, is it true 17? This one. Try to change 10001. Okay, so this one is 2 power of what? This is 2 power of 3, right? Okay, what about this one? This one, 2 power of what? Let me take a pointer here. Okay, this one, right. Okay, this one is equivalent to 2 power of what? 2 power of 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3. This one 2 power of what? 4.
Zero.
Okay, what is 2 power of 4, class?
16.
What is 2 power of 4? Tell me.
16.
15.
16, right?
16.
Okay, 16. Okay, what about this one? 2 power of what? 2 power of
0.
0. What is 2 power of 0?
1.
1. Okay, so it is equivalent to 16 plus 1. Okay, is it equivalent to 17? Equivalent, right? Okay,
Yes.
that's why this is the immediate value. Okay, to so this is the immediate value lah, equivalent to 17. Okay, so here when we run this instruction, okay, the immediate value is 17 here. Okay, we'll pass through the ALU. Okay, and it will add. Okay, it will add with the content of register T1. Okay, it will add with the content of register T1. Okay, I mean the content of register T1 plus with 17, and it will point to memory location. Okay, uh, the content of register T1 plus with 17. Okay, the next one is they need to know what is the content of memory location T1 plus with 17. Okay, so this one involve memory read. So this one we call as memory read. Okay, read from memory. Okay, and then when after they read the memory, they figure out what is the content of that memory location, and they will follow with the final step, which is write to register. Write to which register, class? Okay, they are copying the content of memory location pointed by T1 plus 17. Okay, and the result will be stored in which register finally? Register
T3.
T3. Okay, so this is the what I mean by 5 steps instruction. Okay, so don't worry much about the details. Okay, the thing is, just want to show you the difference between 4 stages instruction and 5 stages instruction. Okay, right. Okay, so we then the main objective is to want to show the difference. Okay, the types of stages. Okay, so we can execute whether we can skip the 5th stage, or we can straight away run with 5 stages. Okay, so one instruction can have 5 period of time, or can only have 4 period of time. So if the instruction involve 5 periods of time, okay, the execution time will be longer. Okay, so now we will discover about the pipelining. Okay, right. Okay, so you can see here for load word. Okay, okay. Just now we discover what store word, right? Okay, the store word doesn't involve register write. Am I right, class? Is it true just now? The store word doesn't involve register write. Is it correct, class?
Yes.
Yes, right. Okay, but for load word, it involves until register write. Therefore, which instruction a longer time? Load word or store word?
Lower.
Load word. So load word requires longer time lah to execute. Okay. So this is just one instruction. Let's say your assembly language consists of multiple instruction. So this is the total number of picosecond. So PS is the picosecond lah. That it is in blink of your eyes lah, because picosecond is very short, right? But in terms of CPU, that's why we have overheating and so on. Okay, because the times requires the computer or memory utilization or the CPU utilization, right? Okay, for R format instruction, okay, requires 4 cycles. Okay, so it is about 600 picosecond. So this is basically the rough idea lah. For fetch, so normally it takes about 200 picosecond. Okay, for register read, okay, this is about 100 picosecond. Okay, the execute or ALU operation, it is about 200 picosecond. Okay, for memory access, it is about 200 picosecond, and register write is about 100 picosecond. Okay, so for load word, it requires about 800 picosecond, which is the highest or the longest execution time lah. Okay, and then follow with the store word 700. Okay, R format. Okay, and then branch equal, okay, is also about 500 picosecond. Okay, so what is R format? R is register format, register format instruction. Okay, right. Okay, what can we do to improve the clock rate? Okay, will this improve performance as well? Of course, it will improve the performance, okay, by having the technique we call as pipelining. Okay, right. So this is what the one that we have done just now. Okay, I stress out again. Okay, this is also a popular question. It is just like a tips lah. Okay, so I hope you can faham lah. Okay, right. Okay, so basically pipelining concept. Okay, we want to improve the clock rate. So whenever we improve the clock rate, the performance will be much more faster and will be improved lah. Okay, faster, and will the processor utilization will be improve. Okay, so the analogy is just like performing a laundry. Okay, 30 minutes for washer, 30 minutes for dryer, 30 minutes to fold. Okay, 30 minutes to stasher to put the cloth into the drawer. Okay, so this is only just for one customer. Okay, but if we have about 10 customer, we can multiply lah. Okay, so how many minutes that the following customer or the third or the fourth customer have to wait? Okay, so this is the techniques of sequential laundry. Okay, the first customer, okay, take about 3 times with 4, it is about 120 minutes. Okay, 120 minutes. Okay, right. So after 120 minutes, then only the second customer can perform the laundry. Okay, can you imagine? Okay, how long it takes for the fourth customer to wait? Okay, so this is what we call sequential laundry techniques. Okay, so have a look first. Okay, Okay, as as for solution, okay, as a solution to this issue, okay, we can use a technique we call as pipeline laundry. Means that after we have performed the fetch for the first instruction, after the first instruction have performed the fetch, the first instruction will go into decode, right? Okay, then the following instruction can do with fetch. Why? Because now the fetch is free. Fetch cycle is free. Okay, so same goes to the pipeline laundry. Okay, so whenever the first customer have done the washing, okay, then they will go on to the drying, okay, or dryer. Okay, then the washing is free. So the second customer can do the washing. At the same time, the first customer can do the drying. Okay, so that's why we call as pipeline laundry. And if you refer to this, okay, the first customer have taken the cloth from the drawer. Okay, okay, but the third customer now in the process of folding lipat kain. Okay, but the third customer now do the drying, and the fourth customer is doing the washing. Can you see? Okay, different process can be done at the same time, okay, in parallel. So this one will greatly reduce the time. So you can see the time here: 1, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 cycles, okay, times with 30 minutes maybe. Okay, so in order for the fourth customer, okay, to finish their task, it requires about 16 times with 30. So you count for yourself lah. Okay, but instead of that, by using the pipeline laundry, okay, the third customer can finish their task in about 1, 2, 3, 4, 5, 6, 7. Okay, only 7 times with 30. So it is about 210 second. Sorry, 210 minutes. Okay, so by performing the pipeline laundry or analogy, it will greatly, okay, faster the processing time or enhance the process of performing the laundry. Okay, right? Okay. So this is the idea for the pipelining lah, the concept that we will discover in um, in our microprocessor or in our assembly language techniques lah. Okay, right? Okay, pipelining doesn't have latency of single task. It helps a throughput of entire workload. Okay, means that it doesn't shorten single stages, but it will utilize the total waiting hours. Okay, multiple tasks operating simultaneously using different resources. Okay, potential speed up equivalent to number of pipe stages lah. So we have about 4 pipe stages. So this is the first pipe stage, which is the washing, okay, drying, folding, and stacking into the drawer. Okay, okay, times to fill pipeline and time to drain, it reduce the speed up. Okay, it will speed up the process. Okay, okay, so this is the technique we call as the pipelining lah. Okay, so suppose the washer takes about 20 minutes. Now the stasher takes about 20 minutes. How much faster is the pipeline? Okay, so this one I will ask the question, and maybe I will share a link for you to answer later. Okay, right? Okay, so enough on the laundry pipelining. So we will refer to our microprocessor or our assembly language processing lah. Okay, okay, right. So this is the normal instruction, right? So normally your single assembly language program consists of multiple instruction. Okay, my question is, for load word, how many stages involved, class? How many stages?
5.
4 or 5? Load word.
5.
5, right? We have 5 stages here. Fetch, okay, execute, decode, okay, okay, then execute, and then memory, and then register, right? Okay, okay. So it is about this one for fetch about 200 millisecond, and the smaller one is for register, or which is the decode. Okay, decode is about maybe about 100 picosecond. So this one they are using the picosecond. Okay, picosecond, right? Okay, so this is what we call a single cycle. Single cycles means that all the instruction run in sequence, one after another. Okay, so you have to finish the first instruction, then only you can go to the following instruction. So you can see here, okay, your processing speed will be much longer. You have to wait until the first instruction to finish, then only you can execute the following instruction. Okay, and then goes to the third instruction. Okay. Okay, as a solution, we call a technique we call as pipeline. Okay, okay, can you see here the reduction in total processing time? Okay, instead of 100 picosecond, 800 picosecond, by using pipeline, okay, you can finish in 200 picosecond. Which one is faster, single cycle or pipeline, class?
Pipeline.
Pipeline, right? You can see here, if during the fetch process for the first instruction, after the first instruction have finished, they can go into the decode, right? So while this first instruction go to decode, the second instruction can start with fetch. Okay, so when the first instruction perform the third step, which is the execute, right? The second instruction can perform the decode, and the third instruction can perform the fetch. Can you see here? Okay, multiple instruction can be executed at the same time, and the total duration for running one complete program is greatly reduced. Okay, greatly reduced. Greatly reduced for how many seconds? Pipeline versus single cycle. Reduce for how many seconds? 800 picosecond minus with 200, right? Okay, so what is the difference, class? So you save about
600.
600 picosecond while performing the pipeline. Okay, okay. Are you clear, class? Is it clear, the concept of pipelining?
Yes, sir.
Okay, so remember, this is very important. Okay, so kalau katalah keluar dalam mana-mana assessment, okay, I'm expecting you to score this question. Okay, because you have understood and it is easy for you to answer this question. Okay, right? Okay, so non-pipeline total time. Okay, each column represent one stages lah. Okay, so you can see here. Okay, for non-pipeline, it consume a lot of time. Okay, okay, total time taken to execute for 3 non-pipeline instruction. Okay, for one instruction, okay, okay, 3 instruction. Okay, for one instruction consists of 5 stages, right? Okay, so for one instruction consists of 5 stages. 1, 2, 3, 4, 5. This is only for one instruction. Second instruction also requires 5 stages. 1, 2, 3, 4, 5. Okay, so this is also a popular question. They will ask you to give the total duration. Okay, total time taken for 3 non-pipeline instruction. So 3 instruction times with 5 stages. Okay, then for one stages, okay, the duration is equivalent to 200 picosecond. Okay, 200 picosecond. Okay, so this is also 200 picosecond. Right? Okay, so the total time taken is about 3000 picosecond. Okay, so pipeline total time, if all the stages are balanced, in this case, we take the longest time for a stage to complete. One stage, it is about 200 picosecond. Okay, one stage is just for one stage, it is about 200 picosecond. So for one instruction, what is the total duration, class? How many picosecond for one instruction, complete instruction?
1000.
1000. 200 times with 5. So for only one instruction, it requires about 1000 picosecond, right? Okay, so one cycle. Okay, total time required for a pipeline with k stages for execute n instruction can be expressed for this formula lah. Okay, right. So the important thing is you understand this part. Then you should be able to answer the question. Okay, right. For pipeline, okay, the same instruction, but for a pipeline processor, okay, right? Okay, the total time is much reduced. Why? Okay, 3 instruction, okay, at some stages can run in parallel. Okay, so for one stage equivalent to 200 picosecond, okay, picosecond, right? Okay, so in order to execute 3 instruction, what is the total duration class? How many picosecond for pipeline? This example. How many picosecond? Quick.
1,400.
1,400.
400.
So it is equivalent to, okay, 200 picosecond. Very good. Okay. Okay. Kali dengan or times with how many stages? Okay. How many stages lah, in which the stages is in the form of a pipeline. Okay. So times with 7. Okay. So the total duration in order to complete this program is only about 1,400 picosecond. Okay. What about the previous one? How many picosecond? 3,000. Can you see the difference? Okay. 3,000 picosecond. Okay. So 1,400 picosecond for pipeline is a shorter period compared to 3,000 picosecond for non-pipeline program. Okay. Right? Okay. Okay. Are you understood, class? Understand, everybody?
Yes, sir.
Yes, sir.
Okay. Okay, pipeline speed up. If all the stages are balanced, all take the same time between instruction, equivalent time between instruction divided by number of stages. So this is the other way around. Let's say you want to find the time for each instruction for each stages. So you can use this formula. If not balanced, speed up is less. Okay, speed up due to increased throughput. Okay, latency time for each instruction does not decrease. So this one you can investigate later lah. Okay, so that we are not get confused in the later evening. Okay, right? So this one we can investigate later. Okay, ideally 5 stages pipeline should offer nearly 5-fold improvement over the 800 picosecond non-pipeline time. So you can see here it is a great reduction. Okay, from 3,000 picosecond we have reduced by using the pipeline technique to 1,400 picosecond. Okay, this one is the pipeline performance. Refer to slide 10. Example does not reflect for 4. Okay, so you can skip this one. Okay, so by having this slide indicates the end of the first part of our slide lah. Okay, so we have done the I-type instruction, and then we have gone through the introduction to pipeline. Okay, finally implementing the pipeline in single cycle data path. Okay, right. So basically, in general, okay, single stages consist of 5, which is the fetch. Okay, IF is for instruction fetch. Okay, ID is for instruction decode. KEX for the execute. Okay, mem is for accessing the memory. Okay, WB is for write back to register. Okay, right. So this is a single cycle instruction. Means that you have to perform the fetch, decode, execute, okay, and then read from memory, and then write to register. Okay, right. Okay, so by having pipeline concept, you need to have few registers. Okay, you need register between the stages. Okay, right. Okay, so regarding this part, okay, we will discuss during our later session lah. Okay, so for the time being, we just digest, or we just understood about the pipeline, the basic pipeline technique first. Okay, right. Okay, until this point, any of you have any question before we end our lecture today? Any question? Okay, bear in mind, like I have mentioned earlier, okay, the second half of the semester, starting from assembly language, okay, until the end will be covered in your final exam. Okay, and once again, I stress to you, okay, the one that I focus now is the one that important for your final exam. Okay, right. Okay, class. Any further question before we end our lecture?
No, sir.
No question. Okay, so I will share the notes, and I will share the recording as well for your future reference. Okay, right. If no question, okay, till we meet again. Okay, so most probably for lab, I'm not mistaken, tomorrow supposed to be G2, right? Am I right? Betul ke? Tomorrow G1 or G2 lab? Class tomorrow is lab for G1 or G2?
G2.
G2, right? Okay, for G2, okay, and for G1 as well. Our lab as usual on Friday. Okay, so you can have a revision day, or you can have a rest day tomorrow lah. So if I have anything for you to add your coursework marks, okay, I will let you know by tomorrow lah. Okay, right. So once again, our lab for G1 and G2 will be on Friday. Okay, as usual. Okay, with that, I end my lecture today. Okay, thanks to all. Assalamualaikum.
Thank you, sir.
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 Thank you, sir.